Hello engineers, this is Team 212G from the Pythons here with a video tutorial. The parts I will be using in this video can be downloading from the Vex Robotics website. Many VAX challenges require a robot that can move, and modeling a drivetrain can be an important step in the design process. To achieve this design, I will use Autodesk Inventor to demonstrate what the process for modeling a drivetrain might look like. In a new assembly, I'll start by inserting a C channel to mount my first motor onto. Every motor and shaft needs a bearing flat to hold it, so I create axes in the holes of the C channel to constrain the holes of the bearing flats too. I'll insert the screws first so I can constrain the motor to them, using insert and make constraints. The motor is on the wrong side by default, so I need to change the solution and offset it farther down the screw. I then put screws with caps nuts on the other bearing flat to realistically secure it to the C channel. I use the joint command to insert a shaft into the motor, and a shaft into the bearing flat. I also use it to put shaft collars, spacers, and gears onto the shafts. Motion constraints can be applied to have the shafts rotate with the gears. The gears will not move each other until you apply motion constraint between the two. I'm sure you already know what gear ratio is, but here is a reminder. Mechanical advantage, or gear ratio in this case, can be calculated with input divided by output. 36T divided by 12T is 3. So our gear ratio is 3:1. In a real drivetrain, both ends of the shaft should be held in place by bearing flats. So, I add another C channel on standoffs to make this system stable. You can also add a wheel and move the gears around to simulate your drivetrain in action. Although a program like Autodesk Inventor takes experience to use efficiently, undertaking a task like designing an entire competition robot can provide you with time getting used to using it. I hope this video was helpful, and remember to have fun engineering.